Okay, so moving on to question number 5. They say here, figure 2 shows a sketch of part of the graph of the curves curve 1, C1 and C2. So we can see C1 and C2, the two curves. The curves intersect at x equal 2.5 and when x equals 4. A table of values for some points on the curve 1 is shown below with y values given to 3 decimal places as appropriate. Okay, so table is filled. Using the trapezium rule with all the y values in the table, find 2dp and estimate for the area bounded by the curve 1 and the line with the equation x equal 2.5, the x-axis, and the line with the equation x equal 4. So basically, so you all should know the trapezium rule. It actually gives you the area in between the two selected x values. So here my x value is between 2.5 and 4. The area under the curve 1, so the curve 1 is this guy. So I'm going to get the area under the curve 1 between the x limits 2.5 and 4. So basically, I'm going to end up getting this area, isn't it? I'm going to end up getting this area. So let's get that area. So how do we get that area? Question number 5, part A. So trapezium rule. So area equals half into h. Y0 plus 2 times y1 until yn minus 1, the middle y values, plus the last y value. Okay. So in here, y'all should know y0 is the very first y value. Yn is the very last y value. So these are the y1, y2, the middle y values, right? And what is h? H is actually the gap. Now, you know, you are the x values are equally placed. There's an equal gap in between all these x values. So those are the trapeziums, the strips we have. So we are actually, you know, dividing this into trapeziums, isn't it? An equal number of strips. So h is actually the gap that you have between, I mean, each and every strip. So this gap you have between the strips, so that is the h value. So we don't need to go into that detail. All you can see is just look at the difference here. So I think very clearly you can see the difference is you can subtract 2.75 minus 2.5. So take any two consecutive x values and subtract. So it's 0.25. That's going to be your h value. H equal 0.25, the gap. So let's apply the trapezium rule now. Area equals half times h is 0.25 into y0. So put the y values. Be careful. Don't put the x values. The y value is 5.453 plus twice the middle y value is 7.764 plus 9.375 plus 9.964 plus 9.367. So those are the middle y values, right? I used them correctly, right? 7.764, 9.375, 9.964, 9.367 plus 7.626. So there's one more. Plus 7.626. And then find the final y value is plus 5. Okay, so now it's a matter of typing the whole thing in the calc. So what I'll do is first I'll get the middle values. I'll add the middle y value 7.764 plus 9.375 plus 9.964 plus 9.367 plus 7.626. So when I add them, I get 44.096. So let's put it here. Area equals half into 0.25 into, so here I just added the middle y values, that's all. 5.453 plus twice of what was the answer we got inside the bracket, 44.096 plus finally there's a 5. So I just added the middle y values, so I wrote that answer. So times this. So now finally the whole thing in the cal one last time. So half into 0.25 into 5.453 plus twice of 44.096 plus 5, right? So you get this, and then the final answer you get as 12.33. So area equals 12.33. 12.33. So let's get a few more decimals. 12.330625. So how far have they asked us to how many decimals? So find the two decimal places and area of the estimate. So to two decimals. So area equals to 12.33. So your area equals 12.33. Okay, so that's the end of part A. So the approximate area under the curve 1 in between these two x figures. So the kind of like the area that I've colored, that area is 12.33. So moving on to part B. The curve 2 has equation y equal x to the power 3 over 2 minus 3x plus 9. Find the integration. Okay, so we just need to simply integrate. So let's go on to part B. So integrate x to the power 3 over 2 minus 3x plus 9 whole thing. So when you integrate, you know the rule, you add 1 to the power 3 over 2 plus 1, that's 5 over 2, divide by 5 over 2, minus 3 times x to the power 1, add 1 is going to be 2, divide by 2, plus simply when you integrate a constant 9 with respect to x, so it's going to be 9x. And don't forget the plus c, right? So let's simplify this a little bit. The 2 in the denominator, it comes up, so 2 over 5 x to the power 5 over 2 minus 3 over 2x square plus 9x plus c. So this is the answer for part B. Okay. Okay, so then moving on to part C, the last part. The region R shown shaded in figure 2 is bounded by the curves C1 and C2. Okay, so region R. So we need to refer back to our diagram. Let me erase all this. So the region shown R, okay, so we can see in our diagram, the region shown R in shaded figure 2 is bounded by the curve 1 and curve 2. Using the answers to part A and part B to find the 1 dp and estimate for the area of the region R. Okay, so they are asking us to get an estimate for the area of the region R. So you need to know exactly what we need to do here. Now curve 2 equation is known. We actually integrated in part B. So what I need to do is I need to find the area of this, this part. So in part A, actually, you saw that I found the area of curve 1 in between 2.5 to 4. So in that particular case, I got this entire area, isn't it? I got this whole area that I'm marking in yellow. I got the full area. That is the approximation of the area under the curve 1 from the trapezium rule. So this yellow color area, I got it as 12.33. So now to get the shaded area, I think you can see, you can agree with me that I need the area under the curve 2, isn't it? I need the area under this curve 2. So I kind of need this area, this red color area. So from there 12.33, the full area, if I can subtract this red color area, I can end up getting the shaded region R. So what I need to do is here, simply I need to get the area under the curve 2. So the curve 2 equation is given. All we need to do is we need to integrate our curve 2 between 2.5 to 4. So we need to integrate part C to get the answer underneath curve 2. We need to integrate x to the power 3 over 2 minus 3x plus 9 with respect to x from between the limits 2.5 and 4. Can you all see? So these are the x limits. I need to integrate my curve 2 between 2.5 and 4. So I think you can see now they tell us very clearly we must use the answers from part A and part B. So the integration is actually done. I don't need to again integrate. So the answer is directly there, 2 over 5 x to the power 5 over 2 minus 3 over 2 x square plus 9x. So when you are doing integration with limits, you don't need to put the c. Plus c is not needed. So you're going to use the limits here. So now let's type the whole thing in the cal. So what I prefer to do when I do something like this to save time, I type the whole thing in the cal, 2 over 5 x to the power 5 over 2 minus 3 over 2 times x to the power 2, so x square plus 9x, right? 2 over 5 to the power 5 over 2 minus 3 over 2 x square plus 9x. Okay, so now it's quite easy. So calc and we need to give the x value, x is 4. So that gives me 124 over 5, because the first thing I should do here is I have to put the limits 4 and 5. So kind of like if I show what I'm doing here, this is 2 over 5 times 4 to the power 5 over 2 minus 3 over 2 times 4 square plus 9 into 4. So this, subtracting it using x as 2.5. So replace all the places where you have x with 4 and 2.5. And you can let the cal do the hard work. Right, so I replaced everywhere x with 4. Then in the middle you have a minus sign, and then you replace all the x values with 2.5. So I'm not going to type like that in the cal. I just have the general equation typed in the cal. So I give the first example of x is 4, which gives me 124 over 5, right? 124 over 5. Subtracting with the next part. So the next part, calc x is 2.5. So replace x with 2.5 and I get, so that I get decimal figure 17.0778. Take a little bit of a few extra decimals. So now let's subtract the two values. 124 over 5 minus 17.0778 and we get 7.722. So now what we do is, so I have found the area under curve 2. So that's the area under curve 2, the red color area. So to get the shaded area, you know what we should do? So shaded area equals, we have to subtract the area under curve 1, which was 12.33 from 7.72, right? So 7.722. So anyway, we get the answer. They want it only to one decimal place. So what's the figure we get here? 12.33 minus 7.22, 7.722. We get here 4.6, 4.608, which means correct to 1 dp, 4.6. So the shaded area, the area of the shaded region R will be 4.6. Okay, so moving on to question number 6. The circle has equation x square minus 6x plus y square plus 8y plus k equals 0, where k is a positive constant. Given that the x-axis is a tangent to the circle, find the value of k. Okay, so what we first do is we will try to make this into the standard circle equation by completing the square and by getting it into the format x minus a square plus y minus b square equals r square. So this is the format that we will be working with. So let's work with this x square minus 6x plus y square plus 8y plus k equals 0. So let's work with this. So I'll be taking these two guys and I'll complete the square. So x minus half the value of 6 is 3 square minus and square of 3 is 9. So, and then I'll take the next two. So y square plus 8y. So y plus half the value of 8 is 4, close bracket square, minus 16 and plus k, right? So you can see I have completed the square here. So I end up getting x minus 3 square plus y plus 4 square. So I'll take these guys to the other side. 9 minus 9 minus 16 is plus 25 minus k. Right, so this is the circle format, x minus a square plus y minus b square equals r square. So 25 minus k is my r square. So now they give us a clue here. They're asking us to find the value of k, and they've told us that the x-axis is a tangent to the circle. So let me try to try to kind of like draw this and show. So the circle center is at the point. Now when you see x equals 3, y equals 4, we know the circle center. The center of the circle is at 3 comma minus 4, isn't it? Radius is r square is 25 minus k. Center is 3 comma minus 4. Okay, so let me draw this on a diagram quickly. So this is the x-axis, this is the y-axis, 3 comma 4. So 1, 2, 3. Let's say this is 3. It's better to take a smaller scale so the circle becomes smaller. 1, 2, 3. This is 1, 2, 3, 4. So minus 4. So your circle center is at 3 comma minus 4. And what do they say? They say here very clearly that the x-axis is a tangent. So x-axis is a tangent to your circle. So which means this axis should be a tangent to your circle. So then how do we draw the circle? So my circle must just touch the x-axis. My circle must simply touch the x-axis, isn't it? So you can see immediately this proves that, this gives me the idea that this particular length is the radius. Why? Because my circle should just barely touch this. I mean, it's supposed to be a tangent, right? So it's supposed to be a tangent. So the circle is supposed to go like this. I mean, go something like this, isn't it? So I'm not going to draw. God. So it's not that good. Okay, anyway, the radius. So we understand since our x-axis is the radius, since our x-axis is the tangent, this particular distance that I mark here should be the radius, which is equal to how much? So this is 4 units along the y-axis. So your radius is 4 units. So you understand that the radius is 4 units, which means r square equals to 16. So equal to r square. So r square equals to 25 minus k, which is 16 equals 25 minus k. K equals to 25 minus 16, which gives you k equals 9. So that's the answer of that. Part A, k equals 9. So moving on to the next part. The circle meets the coordinate axis at the points R, S, and T. Find the exact area of the triangle RST. Okay. The circle meets the coordinate axis at the points R, S, and T. So they've not told which is which. But I think we can see, I've kind of drawn a good diagram here. So I think we can see what it is. We can take this point. So the point 3 as R. So the other point here is, the other point here T. So R, S, and T are all found. Not found, I marked them. So I now need to find the exact area of the triangle RST. So triangle RST in the sense, this triangle, isn't it? RST. So this triangle. So I need to get the area of this particular triangle. So let's get it done. So R coordinate, we all know it's 3, 0, right? R is 3, 0 because this was directly 3. So now I need to find these two guys. So these two guys are the place where your circle meets the y-axis. So when your circle meets the y-axis, I'll do part B over here. So when circle meets the y-axis, or when you cross the y-axis, you know x will be 0. So let's go to our equation. I think we can work with the expanded equation if you prefer, or if you want, you can work with the you can work with this one, the factorized one. So I think maybe the expanded one is easier. So x is 0. So let me substitute. So x square minus 6x plus y square plus 8y plus k. K was found to be 9, right? Equals 0. I replace the k with 9. So now the x values are replaced with 0, and I get this y square plus 8y plus 9 equals 0. So now it's time to factorize this. So let's try to get the answers. It's a quadratic equation. It's a quadratic equation. So let me type it in the cal. I think it doesn't factorize, right? Mode equation 3. So y square 1 8y plus 9. So I get here. So you can see we get third answers, right? So I think we could maybe complete the square and show our answer, or we could use the formula. So anything. So y equal minus b plus or minus square root b square minus 4 into a into c is 9 divided by 2 times a is 1, right? So you know the quadratic formula, or you could even apply completing squares. So no issues. So I think you just need to show some kind of a method here to get the marks rather than just writing the answer. So I advise you to write the method, right? Either do the completing square and show a step, or at least use the quadratic formula. Just substitute, and you can write the as long as your substitution is done correctly, you don't have to worry. So here x1 is minus 4 plus root 7. So the first answer, minus 4 plus root 7. Or the other answer for y is gonna be minus 4 minus root 7. Okay, so these are the two y values. So I think you can see minus 4 plus root 7 is a little large, isn't it? So it's minus 1.35. So with that we can identify who is which is which. So SC is larger, T is smaller. So I can see minus 6.64. So S should be the coordinate, the y coordinate of point S should be so this is gonna be 0, minus 4 plus root 7, and the y coordinate of point T is gonna be 0, minus 4 minus root 7. Okay, so we get these two. So now it's time to get the area. So I have I found the coordinates of S, T, and R. Time to get the area. So basically I'm going to use this basic triangle area equation, half into base into height. So when you have a triangle in this manner, When you have a triangle in this manner, so how do we get the area? So I just drew it separated so that you could see it properly. So you guys should know that this when you can so this particular length is going to be your base, and this should be your height. So this is the base and this is the height. Okay, so the base length, I think you can see we need to the base length, by the way, it's supposed to be the length. So take the modulus. I mean, I don't want to take the negative length here, just take the length. I mean, when you subtract these two guys, you can get the length, and make sure you remove the negative sign. So I'll subtract these two guys to get the base. The base of the triangle, if we subtract the modulus of, so I'll subtract -4 minus root 7 with -4 plus root 7, right? So we need to subtract these two guys. So when I subtract this, I get this length because it's on the vertical axis. So when we subtract these two, we get, we don't need the cal here. We could do it manually. So -4 minus root 7 plus 4 minus root 7, isn't it? So -4 and +4 cancels, you get -2 root 7. So -2 root 7. So I just need the base length. So I don't need the negative sign of this. So base is simply 2 root 7. So I just put this modulus sign. Don't worry about this. It's just to say that I want to have the positive value here because I'm getting a length. I'm trying to find the area and I need positive figures for the area, for the length. So I just use the modulus sign here to say that I'm taking a positive figure here. And then what about the height here? So this height, the perpendicular height of your triangle. So if you look at this, so this figure is going to be your height, isn't it? So the x-axis figure, so this is simply 3 units. So your height is going to be 3. So height equals 3. So now everything's done. Just to get the area equals. So area equals half into base into height. So half into base is going to be 2 root 7 into height is going to be 3. So exact answer, half and 2 cancels, you get 3 root 7. So 3 root 7 square units. So that's going to be your area for the triangle RST. Okay. Okay, moving on to question number 7. Given that 3 logarithm of 2x minus 1 to the base of 3 equal to plus logarithm of 14x minus 25 to the base of 3, show that you get this. Okay, so it's quite simple. What you do here is 3 times of part A, 3 times logarithm of base 3 2x minus 1 equal to 2 plus log base 3 14x minus 25. So how do we work with this? So now when you have logarithms, we bring everything to one side and we try to have addition, subtraction. If you have such thing in logarithms, we try to we can write them as a division or multiplication under a single logarithm. So what I'll do is I'll bring this log base 3, this particular term, to this the other side, to the left hand side. And I'll have here 3 log base 3 2x minus 1 minus logarithm of 14x minus 25 to the base of 3. So I brought it to the other side. Okay. So now you can see we have a subtraction between 2 logarithms. And normally, if you have a subtraction between 2 logarithms, so log A minus log B, if it's the same base, you could write it under a single logarithm as a division, log A divided by B, under a single logarithm. But in here we can't immediately go for that because outside you can see there's a 3. So while this 3 is over here, this guy is looking okay, it looks fine. But here you have a 3, so you can't immediately go for the division here. So you'll need to fix it. How do we fix it? We can take this 3 outside, we can take it inside our logarithm as a power. So you get here log base 3 2x minus 1 to the power of 3 minus log base 3 14x minus 25 equals 2. So you get here log base 3. Now we can write inside as a inside under a single logarithm. So 2x minus 1 to the power 3 over 14x minus 25 equals 2. Okay. So now we can work on this. So we get here 3 to the power. Now it's time to turn log to index, right? So 3 to the power of 2 equals 2x minus 1 whole thing cube divided by 14x minus 25. So now it's a matter of, simplifying this whole thing, and you should end up getting this equation quite easily. Okay. So 3 to the power 2 is 9. I'll bring the 14x minus 25 to the other side as a multiplication. 2x minus 1 cube, you could open, expand binomially. I mean, doing binomial expansion, or you could do manual. So I'll just open manually. So 9 into 14. So that gives me, so 9 into 14, 126x minus 9 into 25. That gives me 225 equals, so let's open the bracket here, 2x minus 1 bracket is going to be there. While we expand the other two, 2x into 2x, that's 4x square, minus 2x, that's minus 4x, minus 1 plus 1. So 126x minus 225 equal, opening the bracket, 2x into 4x square is 8x cube, minus 2x into 4x, 8x square, 2x into 1 is plus 2x, then minus 1, now open the bracket with minus 1, minus 4x square, plus 4x minus 1, right? So minus 4x square plus 4x minus 1. So now it's a matter of taking everything to one side, and I think it should quite easily rearrange itself to give you the showdown. Okay. So I'll simplify this side from here. So 8x cube minus 8x square minus 4x square minus 12x square. 2 plus 4, 6x minus 1, and we bring these two guys to the other side. Minus 126x plus 225, right? So I end up getting here 0 equal 8x cube minus 12x square plus 6x minus 126x should give me minus 120x plus 225 minus 1 is 224, right? So the show that has 2x cube, which means the show that has a 2x cube, right? So which means this guy I should divide to get 2x, so I should divide the whole thing by 4. So means the whole thing should be easily divisible by 4. So let's divide 0, 8 divided by 4, 2x cube. 12 divided by 4 is 3x square. 120 divided by 4, that's 30x. 224, that's 4 times 5 and 4 times 6, right? Yes, so do we get the show that 3x, 2x cube minus 3x square minus 30x plus 56 equals 0, which is your show that for 4 marks. So in show that questions, don't be thrifty, show the steps, because you need to show all the possible method steps to get the marks. Okay. Okay, so else if you don't like to do this manual expansion, you could always go for the binomial expansion and directly expand in maybe two steps. I just did the manual method because I just felt like that at this moment. Okay, so you could binomial expand it. It should have been easier, I think, and time saving. Okay, part B, show that x equal minus 4 is a root of this cubic equation. So x equal minus 4. So minus 4 is a root. So x equal minus 4. So you take the fx equation. So we let fx be 2x cubed minus 3x square minus 30x plus 56. This is our fx. So if it's a root, if a certain value is a root, when you substitute that over here, you should end up getting 0. So 2 into, you get here minus 4 cubed minus 3 into minus 4 square minus 30 into minus 4 plus 56, right? Okay, so let's work with this. So let's put it on our cal. 2 into minus 4 cube. 2 into minus 4 cube minus 3 into minus 4 square. So make sure the minus, when you're giving these powers, the minus 4 minus, the minus 4 is surrounded, it has brackets. Okay, otherwise if you give the power without the brackets, especially the even powers, the minus mark will not be accounted for. The minus mark, the power will not affect the minus sign. So be careful. Make sure when you're giving these things, you do put a bracket around your negative 4 when you're giving the powers. Okay. Then minus 30 into minus 4. This of course does not have a power. It's okay. So I'll just put the bracket out of practice. So 2 into minus 4 cube minus 3 into minus 4 square minus 30 into minus 4 plus 56. So if I have this correctly, I should get 0. So let's see, equals 0, as you can see. So when you put x equal minus 4, the answer is 0. So therefore, if your answer is 0, therefore x equal minus 4 is a root of this equation. Okay, it's a root. It's one of the roots. Okay. So then part C, hence using algebra and showing each step of your working, solve 3 log base 3 2x minus 1 equal to plus log base 3 14x minus 25. 4 marks once again. So now you guys can see obviously, hence we will be using the help of part A and part B, using algebra and showing each step of your working. We need to solve this. So as you can see very clearly, this is exactly what you have in part A, right? So this is exactly what you have in part A. So in the process of simplifying part A, we actually came to this equation, isn't it? 2x cubed minus 3x square minus 30x plus 56. So that is actually solving, I mean, that this particular equation, this cubic equation should give you the solutions for your logarithm, for this logarithm question. Should give you this, it should give you the necessary solutions. So you can see now it's a cubic equation that I need to solve. And I mean, they've given us a little bit of a clue in part B because they've given you one solution. So one solution is x equal minus 4. But you know, it's a cubic equation and you know, there will be 3 solutions. So cubic equations, normally you should get 3 solutions. So there's one. So there are 2 more solutions to be found. So let's find them. How do we find them? So in part C, we know x equal minus 4 is the root of the equation. It means, in other words, if you remember the factor theorem, x equal minus 4 is a root means x plus 4 is a factor. So x plus 4 is a factor of fx. So to find the remaining factors, you could try the long division method. So the long division method, you have here 2x cubed minus 3x square minus 30x plus 56. So this is gonna be divided by x plus 4. So when you divide, the quotient should give you the remaining factors, the 2 remaining factors. So your quotient will obviously be a quadratic, it will be a quadratic. So let's divide 2x cubed divided by x, it will give you 2x square. So this gives you 2x square. So let me multiply 2x square with x plus 4. 2x square into x is 2x cubed. 2x square into 4 is plus 8x square. So let's subtract. So 2 minus 2, 0, minus 3 minus plus 8, that's going to be minus 11x square. Let's bring it down and we have here minus 30x plus 56. So then we'll divide the minus 11x square by x, and the next term we get here is minus 11x. So when we multiply minus 11x with x plus 4, I end up getting minus 11x square. Minus 11x into plus 4 is minus 44x. Subtract. So this is 0 minus 30x plus 44. So minus 30 plus 44 gives me plus 14x, right? Plus 14x and then bring down the 56. So next step, divide 14x by x. So that gives you plus 14. So 14x into x is 14x. 14 times 4. So that should be 56, right? 14 times 4 is 56. When you divide, this is going to be fully 0 when you subtract here. So you can see it's a perfect division. So if it's a factor, obviously you expect the remainder to be 0. It should be it should do a perfect division here. Your quotient gives you the remaining factors. Okay, so fx, the factors are x plus 4, 2x square minus 11x plus 14. So typing in the cal and let's factorize the quadratic even further. So a is 2, b is minus 11. So ax square bx plus cc is 14. Right? So you are already familiar with this. X equals 7 over 2. So you guys should know how to factorize this now. X equals 7 over 2 means the factor is 2x equals 7, which means 2x minus 7, right? Just to show you, because you need to, factorize this perfectly so that when the brackets expand, that it does not, it should not be different from the answer, I mean, from the quadratic we have over here. The other answer is x equal to, which means the factor is x is minus 2. So x minus 2, right? So is this clear? So we have x equal 2 means x equal minus 2. So that's the factor. So now it's a matter of finding what fx is 0, right? So you make this equation equal to 0. This equation should be equal to 0 and you can find your x values. So x plus 4 equals 0 or 2x minus 7 equals 0 or x minus 2 equals 0. You get x equal negative 4 or x equals 7 over 2 or x equals 2. Okay. So we get these three answers, and so be just a word of caution here. So don't. So many people would, they would get the x values and they would stop from here. But no, there is one more step that you need to do here. We are dealing with the logarithm sum, right? So we are trying to solve. Actually, our point, the point of the question was to solve the logarithm. I mean, the cubic equation was a result of solving the logarithm, right? But the solutions of the cubic equation are not always going to 100% agree with our logarithm, in the sense, logarithms, you can't have inside of a logarithm, I mean, regardless of the base. Yeah, the inside of the logarithm, if you have a negative figure, it's not defined. Logarithms are not defined for negative figures, right? So you can't have a negative 5 or any negative figures here. So what I want you all to do is, I mean, after you get your x values, so you need to do one more thing here. So if I write my sum, 3 log base 3 2x minus 1, 3 log base 3 2x minus 1 equal to plus log base 3 14x minus 25, right? I wrote the sum correctly. Base 3 14x minus 2. Okay. So now what you do is, y'all need to check, I mean, with these x figures, whether there will be any x figure who will give you math error, in the sense where the inside of the logarithm becomes negative. So I think you can see when x equals 4, I can very clearly see here this logarithm is definitely going to be negative. 2 into minus 4 minus 8 minus 1 minus 9. So when x equals minus 4, the equation will not be defined. You can't define a negative logarithm. So x equal minus 4 is definitely not going to be a part of a solution for an equation like this. So you can't take x equal minus 4. X equals 7 over 2, I think you can substitute. It looks okay, right? Yeah, so it looks okay. There won't be a problem. The figures are positive. I'm just putting the values here. And when x is 2, 2 times 2, 4 minus 1, that looks good. 14 times 2, 28. Yeah, so it's positive. Can you see? So for these two figures, these just check the inside of the logarithms to check whether you get positive figures, because the inside of the logarithm must be positive. This figure must be positive. Okay, it must be positive for the equation to be defined. So for x equals 7 over 2 and x equal to, these two figures are positive, while for x equal minus 4 it's negative. Therefore, your final solutions for x are x equals 7 over 2 and x equal 7 over 2 and x equal 2. So these are your two solutions. Okay, so x equal minus 4, you must reject the solution x equal minus 4. Okay, moving on to question number 8. So in this question, we must show all the stages of our working and solutions relying, because you can't use entirely a calculator. Okay. So let's work on this. Solve for theta in the range between 0 to 360. The equation 3 sine theta plus 30 equals 7 cos theta plus 30, giving you answer to one decimal place. So let's start on this Roman number 1. 3 sine theta plus 30 equals 7 cos theta plus 30. So actually you can see we have a compound angle here, because you have addition. I mean, there is the angle, it's not simply theta, but rather theta plus 30. So when you work with a compound angle, so my advice is to use a letter here. So let x, use some letter that you've not used in your calculations. So let x be equal to theta plus 30. So we don't have any x anywhere else. I think better to use a different x. I mean, it's fine. Just use some letter that's not used anywhere else. So then, so your y equals theta plus 30, which means we get here 3 sine y equals 7 cos y, right? And then when you're changing the letter, also remember you must change your range. Now our range theta is in between 0 to 360. So when you have theta plus 30, so you will add 30 to the range. 0 plus 30 is 0, 360 plus 30 is 390. So your y will be between 30 and 390. Okay, so we end up getting sine over cos is tan. So tan y equals 7 over 3. Okay, so tan y equals to 7 over 3. And now it's time to use the quadrants, all silver teacups. All silver teacups, quadrants where tan is positive, all and tan. So all and tan are the quadrants where tan is positive. So they want in degrees. So make sure the cal is in degree mode. So cal in degree mode, and let's type tan inverse 7 over 3, and we get the answer 66.801. So let me mark the acute angle. So 66.801. So let's write the answers now. Go around. We have to go start from 30 going on to 390. So the first answer for y will be, so when you go around, the first answer we get is 66.801. And when you keep on, you keep on and you get the next answer 180 plus 66.801. Right, so when you add this is to 1 dp, right? So 66.8. So the next answer 180 plus 66.801. So that gives me 246.8. 246.8. So these are the answers correct to one decimal place. Moving on to Roman number 2, show that the equation 3 sine cube x equals 5 sine x minus 7 sine x cos x can be written in this form. Okay, so I can see in this form. So look at this form and try to understand like what they have done. So I can see that they brought everything to one side because the equation is equal to 0, which means everything has been, they've brought everything to one side. And I can see sine x has been factorized out, right? So sine x has been factorized out, and then the remaining inside is cos x. So let's do that for part B. So the equation is 3 sine cube x equals 5 sine x minus 7 sine x cos x. So what I'll do is I can understand that, as I told you that they've made one side 0, take everything to one side. So 0 equals 5 sine x minus 7 sine x cos x minus 3 sine cube x. So now factorize and take a sine x out as they've done in the show lab. 5 minus 7, so the sine x goes, which means you have 7 cos x minus 3 sine square x. So you can see I've gotten, okay, I've come to some point here, but the inside I need to kind of fix it because in the inside we need to have fully, it should be a quadratic equation with cos. So as you can see here, I have a cos, but I have a sine square. So how do we deal with the sine square? So how do we deal with the sine square? Obviously, we use the rule sine square x plus cos square x equals 1, which gives me sine square x will be equal to 1 minus cos square. So here we have 5 minus 7 cos x minus 3 times sine square x will be 1 minus cos square x. So that is in addition to the other bracket. So be careful. So 0 equals to sine x 5 minus 7 cos x minus 3 plus 3 cos square x. So when I bring everything here, so I get 3 cos square x minus 7 cos x, 5 minus 3 is plus 2. So is that the show that? Is that the show that? Yeah, a cos square x plus b cos x plus c. Yeah. So 3 cos square x minus 7 cos x plus 2. So that's the answer. So ABC, I get 3 minus 7 and 2. Okay. So that's the answer for part B. So then moving on to Roman number 2 part, isn't it? This is Roman number 2, so be careful of that. This is Roman number 2 part is, and now I have to go to Roman number 2 part B. Did I mark Roman number 1 here? Yes. The next one, hence solve for x between minus pi over 2 and plus pi over 2. So x between -90 to +90. So this solving, when you see the range itself, which it tells you that your answer must be in radians. Your answer must be in radians. The range tells you which mode you need to keep your answers in. So here, keep your answers in radians. Hence, obviously, hence means you'll have to use the help of the earlier parts. Hence, all the equation 3 sine cube x. Okay, so this equation, which is what we have in part A. Okay, so how can we solve this? Obviously, we kind of simplified it, the part, I mean, we got this equation simplified to this format. So we just need to keep on simplifying that. So let's keep on simplifying that. So sine x times 3 cos square x minus 7 cos x plus 2 equals 0. So now it's already factorized. So make each factor equal to 0. Sine x equals 0 or 3 cos square x minus 7 cos x plus 2 equals 0. Okay. So then let's work on this. Okay. Okay. So our range is x between -5/1 and +5/2. So sine x, so sine graph, you could either remember the sine graph or you could just take the answer. So sine graph, I think we get something like this, right? So as you can see, the sine graph at pi/2, it's 1. At negative pi/2, it's -1. So we get sine 0 only when x is 0. So in this particular range, your x is in between, for x value is in between -pi/2 and +pi/2. We only get x equals, the x equals 0 gives sine 0 is the only one who gives 0. So there's only one solution here. Then the other guy, we'll have to solve this. So it's a quadratic equation. So I think when we solve it, we need to factorize. So equation 3, so 3x square, so 3 cos x square minus 7 cos x plus 2. As you can see, it's a quadratic equation. So we get good factors here. So the roots are cos x equal 2 or cos x equal 1/3. Cos x equals 2 means cos x minus 2. Cos x is 1/3 means 3 cos x minus 1. I hope you guys can understand the simplification. It's just a simple quadratic. So we get here cos x equals to 2 or cos x equals 1/3. The answer is in our calc. So we know very well cos inverse 2. I mean, if you remember the cos graph, you know your cos graph, just like the sine graph, does not exceed the value 1 and -1, right? So it's in between. Your graph is in between 1 and -1. So you know cos graph can never reach 2. Cos graph, sine graph, they don't go above 1 or below -1, isn't it? So here directly we know there are no solutions here. We don't have solutions here. So this does not satisfy. You don't have such a condition here. So we'll go for the other guy. Cos x equals 1/3. So go to the quadrants and mark the quadrants where cos is positive. All silver teacups. Mark the quadrants where cos is positive. So all and cos. Turn your calculator to radian mode. So turn the calculator to radian mode and type cos inverse 1/3. And that gives me the answer 1.23095. So 1.231 to 3 dB. 1.231 radians. So 1.231 radians. Okay, so that's it. So these are the two angles I have, the acute angle to the x-axis. And now let's write the answer. So the first answer for x here is, so when you go around when you try to go the round, so the first answer is x equal 1.231. And the second answer is going to be, obviously, you know, you can't jump this round and come over here. So you are limited. You cannot exceed pi/2. You cannot exceed 90. So the other way, you can see you're allowed to go -90. So you can go to the other side, which means you go -1.231. So these are your solutions. Final answers are x equals 0, 1.231 or -1.231. So these are all the solutions for the value of x. Okay.